Today in this series on scientific integrity, how we make this wonderful thing called science even more wonderful, I have a very, very special guest, none other than Australia's most famous scientist with an incredible story of scientific discovery, but also with a peculiar and very interesting insight on how science works, how it goes really well on occasions. It doesn't go so well. None other than Professor Barry Marshall. Professor Marshall, welcome.
Thanks, Peter. Great to hear from you.
So now, I should have mentioned one small thing about Professor Marshall, and that is he actually won a Nobel Prize for his discovery of the causes and the cure for stomach ulcers. Now, stomach ulcers before the 1980s was a huge, terrible disease. It basically eats out your stomach and you either live a life of pain or you die early, or probably both. And in those days, they really didn't know what caused it. They thought it might have been stress. They thought it might have been spicy foods. And then Professor Marshall and his colleague Robin Warren comes along and say, well, actually, there's a bacteria called, and I'll probably get this wrong, Helicobacter pylori, which is living inside the gut, and that's causing the ulcers. And the scientific community were a little bit outraged because up to then the consensus was bacteria like that just could not live inside the stomach acids that live inside your stomach, and this couldn't possibly be wrong. And there was a lot of opposition, and then Professor Marshall, in probably one of the most famous episodes of science, decided to prove them wrong by doing an endoscope on him, proving he doesn't have a stomach ulcer. And then he took a concoction of Helicobacter pylori, drank it, and actually gave himself a stomach ulcer, right? In the days when really it was an uncurable thing, but he was pretty clever. He'd worked out a cure as well. It was an incredibly brave thing to do. I don't think I could have done it. It was a little bit crazy, actually. But anyway, he then cured himself, and then everybody had to take him really seriously, even though I think it may have still taken a while before it was fully acknowledged. And of course, he then won the Nobel Prize, I think, in 2005, a totally remarkable story. So, Professor Marshall, firstly, just correct me on the bits that I've got wrong there. But I also want to talk about groupthink. Was groupthink an issue in the sort of the progression of the 20 years that it took you to sort of get this discovery totally accepted?
It was. Once something's a tradition, it gets into the folklore and it's not challenged, well, then it becomes, in quotes, true. And so I guess that's groupthink. And everybody assumes that it's been proven and there's evidence for it, and they'll go along with it. And until you actually have a new paradigm or a new idea which is going to be more efficient, save money, save lives, and things like that, and be easier for everybody, it's not going to change. So there's probably many things like that in our society that people believe that have never been proven. And if you're in science or any kind of proper scientific activity, which is looking at evidence, all these things are opportunities for you, especially in medicine where there are lots of diseases which we don't know the cause of.
Yeah. So a question I'd have is, what are the strengths and weaknesses of the quality system? What bits get us into trouble, and what bits, I mean, in your case, the discovery was totally accepted, Nobel Prize, all the rest of it. So what are the strengths and what are the weaknesses within the quality systems that, so when if we had another Barry Marshall Mark II came along tomorrow and discovered something equally remarkable, would the same opposition happen to them? What are the systems which would cause that problem, and what are the systems that get us out of that, I guess, is the question.
Okay, well, it's a great example. It's practically the best example of sort of unproven, in quotes, facts. It would be ulcers being caused by stress. And so if you can knock that one down, then everything else that hasn't been proven is highly suspect. And what we'd say is that in medicine, and it's a revolution that happened actually in the 70s and early 80s as I was growing up in my medical career, I suppose, was you have to have evidence-based proof of doing some benefit, and that has to be proven in prospective double-blind trials. Now, the point about prospective double-blind trials is you get a real treatment and a fake treatment. The patients don't know what's going on. Some of them are taking placebo. And the importance of them is that if you can show that a treatment works and is better than the current treatment in a double-blind trial, I think the government then is obliged to pay for it. And so as sort of medicine became more socialised, government started paying for things, it created this incentive for people to actually prove it and then get their treatment on the market in a good way. So that was happening as, the Helicobacter story developed in the 70s and the 80s. And, nowadays it's accepted, and the government doesn't have to pay for anything if it's not proven, which thank God for that. Otherwise, we'd all be taking get probiotics and paying for them on our taxpayers' bill.
Yeah, some of the really crazy stuff. But does it still always, I'm not into the medical side, but I was reading up on the I don't know whether you kept up with, but with the Alzheimer's research, where something was wrong and it wasn't discovered, this beta amyloid theory. If you don't know anything about it, that's fine. But there are occasions when something seems to be wrong and it should be checked, as you said, by the government, and that things have improved in that regard, but it doesn't happen. So how do we get over that if you think that is still a problem?
Well, it's a problem because, obviously people in government and politicians are not medical specialists, so they have people advising them in their office. So if you've got a good office and smart people advising, then correct decisions are made. So that's usually the situation. But if you've got someone who's pretty popular and he doesn't know anything, is pushing some alternative medicine or something like that, then the government ends up making wrong decisions and paying for things that are useless. And within reason, this is what I see in a lot of other countries in Asia, where the government is on board with the alternative medicine treatments, which has never been proven. A lot of them, it's impossible to prove them because of just the structure of the whole thing. And people go along with it and think it must be true. So these are people who haven't got a proper scientific education, which is still 90% of the population, I suppose.
Yeah. So what areas of science in general, and I'm talking about, wider than health or the rest of it, might be more susceptible to groupthink or individuals like you're discussing on the alternative medicine who have a lot of sway, where the proper scientific method, where there's got to be constant challenge and looking at the evidence and all of this. So what areas do you think are more or less likely to be affected by those sorts of problems?
Well, everything that's not coming out of chemistry and physics, pretty much. I know you'll be pleased to hear that. So in medicine, if the idea is that somebody turns up, the first thing you do is try to find some evidence of something malfunctioning in a person. Yeah. And if you can't find it, obviously, well, then you do different laboratory tests and you might find something there. And then if that fails, well, then you're left with a person who is unwell or thinks they are unwell, but haven't got anything that you can fix easily. And so that gets into the psychiatric and psychosomatic kind of issues, and they are far more difficult to manage and treat. And but because the data is just not there, and we don't actually have a fundamental molecule or pathway or something that we can fix in all these people. I can take examples of things that you can fix. They're genetic abnormalities like phenylketonuria. We know that that's a thing that's in your DNA. You're born with it. If you keep away from aspartame and those kinds of things, you can grow up into adulthood and be completely normal. And that's, if you like, that would have been some kind of weird madness 100 years ago. Lots of things would have just not been understood. Now, once you understand the fundamental thing, the other one would be Huntington's chorea. Would have been some kind of weird madness. So those things can be approached and a strategy developed, and you can fix them. But if you don't actually have an understanding of the fundamental cause of a disease, for instance, or anything. Well, what can you do about it? You could try different things, and often you end up with something which is a treatment. And a treatment means you can keep doing it and ameliorating the condition. But if you knew exactly what the issue was, then you could cure it potentially, or develop a program that looks for scientific strategies.
Yeah, so I mean, I think I totally agree. If you can get down to those fundamentals, and if you can reduce it to a nice physics or chemistry problem, it's great, and that's essentially what you guys did, I guess. But a lot of science is in complicated areas. I mean, the environmental sciences, it is a complicated field, so there's always, it's not a hard or fast experiment that you can do. Well, quite often it's in that situation. So the problem is probably...
The issue that I have in Australia is that once the government comes on board and funds it, everyone has to do that. And so I know this is what Reef Rebels is about. If it's not the reef, it could be the environment, it could be anything else. So you could see that in Australia, so much of everything is funded by the government. I mean, I've always worked in a public hospital, and my funding has been about 50-50 as far as NHMRC, etc. But I wonder about NHMRC, and I wonder about like CSIRO and what other kind of government-funded institutions are set up. Once they're created to solve a problem a certain way, then the person who doesn't believe that is not going to get funded. Or it's going to be difficult.
What do you think to the idea that in, say, the NHMRC or the Australian Research Council, that's the National Health and Medical Research Council, or the Australian Research Council, of setting aside a certain amount of money almost for, replication studies or integrity studies, so that you try to break that groupthink, or that, that line that's got so set in, that furrow that everybody's stuck in? Do you think that would be a useful way of, ameliorating that problem?
I think it's a good idea. So you could have somebody whose job it was to nitpick the accepted science and have a go at it in a good way. So I know that there's not too many people can afford to spend that time. And I mean, for instance, I know about your activities. And you might say something about clouds or barrier reefs or something. And I say, well, that looks like evidence to me. Somebody drilled a hole in the reef and measured it and went down for 4,000 years. And, there's data, there's CO2, there's isotopes. But I don't have the time. I know that in the past I have had, and you follow it down a rabbit hole, as you say, and you could spend weeks doing that. But it would be nice to have somebody who, a little bit of the government that goes after those things and finds the facts.
Yeah, I mean, what I keep on saying is we actually need to pay for people to do that checking. So I'll come on to, I think that we're running a little bit of a campaign in Queensland to try to get the Queensland government to start extra science checks on mostly agricultural problems, so not medical problems like you've mostly been to do with, but to check the science behind major regulations. And we want the Queensland Productivity Commission, which is kind of like a quasi-independent organisation, to take on some science checking, science auditing roles. Now, the question I'd have, there's two questions. The first is what would be the strengths of that, but I'm actually more interested in what would be the weaknesses, because actually it's most important to look at weaknesses of things. Do you think that would work, or do you think it's going to ultimately fail?
I think it would work, but I'm not sure who would want to do it and how it will work. But you could see there's probably, if you look around the world, there are probably other institutions that have done this, and governments. So I could see that you could have a department or a professorial chair in that area, and you could have PhDs, particularly in mathematics and statistics, and clinical trial people, and you could then, those people could go overseas for a year and come back, that kind of thing. So you could become international. I could really see that it would be like a faculty or something ultimately that would be everyone in every university would want to have one. And then you would have an international reputation or not.
Yeah, well, I mean, I think that is kind of the idea. You want to make it in the accountancy field. They didn't used to be auditors. There were no auditors before about 1850, and auditors became a major part of, you know, the accountancy field. And this is kind of what we're trying to get, that you get it to become a nice, respectable profession, and you become like a science auditor. Perhaps maybe that would work.
So when you're trying to introduce some new idea or concept to solve a problem in medicine or anything really, there's usually something that's already there, some kind of business that already exists to solve that problem as best everyone knows how. And you realize that you've got to, if there's a new paradigm, you've got to kick the old one out. So people who are running a business, making business plans, investing money, and thinking long-term over the next 10 years, something new then comes along underneath it, which threatens it. They're not going to suddenly just throw in the towel and walk away. They are going to keep doing the business, so that you can't just introduce a new idea and just usually expect everybody to grab it. And so that's one of the problems you have. It's not like you're bringing new ideas or strategies into a vacuum. There's already something there. And for instance,
that's right.
Natural medicine, you know, if you
that's right. There's the entrenched views that just because you've challenged them, it's not going to necessarily eliminate those entrenchments. But if they're not challenged, then there's no possibility of that entrenchment ever being removed, perhaps.
So you could, if there's something new that came up, you could actually look at a website, for example, and there are a few medical websites like this that would assess new activities. But people could look at it on, if they're having a bit of an argument, they could look at it on the web. So at the moment with AI, it becomes easier and easier to do this.
Yeah.
And I had this thing, when we originally presented the idea of stomach bacteria causing ulcers, you see, our abstract to the Australian gastroenterology meeting was rejected, and I didn't even get a poster. So recently I submitted, I took that exact abstract, verbatim, and posted it into ChatGPT and into Grok, and by tweaking the question a little bit, I could get a rejection or an acceptance with flowery, wonderful abstract or whatever. But if I put it in and just said, just be totally impartial, ultimately Grok said, well, this is pretty early stuff, and it'd be controversial, it'd be very interesting to discuss it, but not for an oral presentation, but a poster would be excellent. So that is the true answer. But I didn't get a poster. So people can actually do a lot more in a short amount of time lately. And so,
I mean, the idea with the Queensland Productivity Commission is that, I mean, we've got a particular case. We've got some rivers down here, the Mary Burnett rivers. There's a lot of agriculture around them, and they're subjected to Great Barrier Reef regulations. And the argument goes, well, why is that? Because they actually don't flow into the Great Barrier Reef, and the currents go that are 300,000 times bigger, take any water that comes out of the rivers south away from the reef. So that's kind of the argument. Well, why is this? So the idea would be if the Queensland Productivity Commission took this on, they would look at whatever science evidence was there. So they'd presumably call the scientific institutions to say, well, what's the evidence that they should be included, and then work on that to put an argument about, well, maybe this is wrong, maybe that is wrong, maybe that's not as weak, and then end up getting some sort of debate between the two sides. That would be the sort of model that, well, I'm thinking of, but this is early days, and we sort of need people like you to give us advice on what may be the best structure for that. Do you have any sort of comments on that sort of
Well,
process that I've just
I often
outlined?
see something happening or if it affects me. And one of them was, so I did the Cairns Barrier Reef holiday once. And so we're on the boat and they say, oh, look, a lot of people are on this boat. We don't want anyone peeing in the ocean. You've got to go to the toilet because if everyone pees in the ocean, that urea will just go do something horrible to the reef. And I said,
Yeah.
because I've done calculations on air dilution and things, pollution and stuff like that in the past related to radioactivity and isotopes. And so I sort of understand how it works. I'm working at how minuscule the amount of, urea or urine contamination would be if, the tides and the waves and all this kind of, and this little boat comes out and people peeing in the water. Oh,
Yeah.
yes. All of a sudden thousands of crown of thorns turns up.
No, well, that's exactly right. Those are the sorts of things that there's so many of those. I mean, they actually discourage the use of sunscreens because supposedly that when you do the calculations, because nobody actually ever does the calculations because I guess there's in many cases not numerical scientists, but when you do the calculations, the concentrations are just so minuscule that, it's really stretching the credulity that could cause any problems. So, yeah, so that's why we're more interested rather than the actual specific example of perhaps science which isn't backed by evidence. What are the systems which we can introduce to get things back on track? That's what we're really trying to do in the QPC.
Yeah, well, I would, you asked me about it, but I'd be happy to participate in some way. I don't have a lot of spare time at the moment, but I'm freeing up a bit more time. So the thing would be, it's 20 years since we won the Nobel Prize, and people still ask for me to be on committees and do things because I don't just join up on anything that's going to pay me. And, this is the sort of thing I probably do for free anyway, but it means that, for the next 20 years, I don't want to have something on my CV that's bogus. So I'm concerned about the things that I sign off on and agree with, so that there are people around like me who've got a good reputation and have maintained it, and that's more important than you're getting a free ticket to the Olympics or something.
Yeah, I mean, one thing is, I think we'd love it if we could say to the Queensland government, look, you got to talk. Don't talk to Peter Ridd. You got to talk to lots of people about how you might set up this science checking. Talk to the real experts, the people who've really been through it. They've seen both sides of it. They've been around science for a long time. So I think it'd be wonderful if they would, get you over there and ask you some questions about how we might do that. So maybe, maybe that will occur.
So I just remembered that when I was looking for venture capital funding many years ago, and we were being interviewed by venture capitalists. So, I mean, these people, their life depends on making correct decisions. 10 years later, they're going to be broke or they're going to be rich. And they hire people, they have very good committees. And I noticed that I was talking to their assessment committee, who were mostly scientists from failed biotechs. So these people are very hard about the data. What data do you have? Show me what happened. What evidence is there? How's it going to work? And live in the real world rather than live in the blue sky type world, if you like.
Actually, that's a really good idea. We're just running out of time now, but actually it's a really good idea to talk to those venture capital guys. And because as you say, it's, I've been a scientist all my life, so I've kind of lived in the ivory tower, but it's good to get these people from outside. Professor Marshall, we are running out of time now, but thanks heaps for actually joining us on this important discussion.
Okay, thanks very much for inviting me, Peter. Live in the real world rather than live in the blue sky.